When we look at an equation that has an acid plus a base as reactants, okay, how can you tell which one is the acid here? It's got the acid has the H at the beginning. How can you tell which one is basic here? It's got the hydroxide at the end, right? Now, when we talk about an acid-base neutralization, we know that on the pH scale, right, we know that acids go from right smack dab in the middle all the way. So they go from 0, and I'll undo that and I'll write it a lot clearer later, and then they go to about, 6 point something, and then bases start and they go all the way up to 14. Okay, that's our pH scale. Right smack dab in the middle here, okay, I have a pH of what? 7. I have a pH of 7. 7 is considered to be neutral. And anything below a 7 is acidic, and anything above a 7 is basic. Okay, so when we're talking about acid-base neutralization, what we're talking about is taking an acidic substance on this side of the equation and adding a basic substance to it on this side of the equation in hopes that we bring the resulting solution right smack dab in the middle to a neutral solution. So if I look at these two here, if I have an acidic solution, hydrochloric acid is pretty acidic, and I add sodium hydroxide to it. A hydroxide is basic. When I combine those two, okay, something magical happens. And it's always the same thing that happens. An acid-base neutralization always involves an acid being combined with a base, and that is going to give us a salt plus H2O plus water. An acid plus a base yields a salt plus water, always. And here's the reason why. Do you remember when we talked about bonding and molecules, and how bonding is atoms that come together and they give electrons and they take electrons, or they share electrons? Do you remember that? So here's what happens. Right now we've got two couples. Okay, we got H and Cl, they're one couple, and we've got Na and OH, they're another couple. And what happens when you combine an acid plus a base is both of these couples here break up. The hydrogen goes one way, the chlorine goes the other. They go their separate ways. NaOH, the same thing happens. Okay? The sodium goes one way, and the hydroxide's like, see you later. So we know that the law of conservation of mass states that you can't get rid of atoms. You can't make up new atoms out of nothing. So what ends up happening is we get a good old swapperoo here. All right? This molecule here combines with this one. Which one goes first, the metal or the non-metal? Which one's the metal? Sodium is the metal. Chlorine is the non. And look at that. You're left with one H and one OH. How many H's are there that you're left over with? 2. How many O's? 1. When you combine that, what does it give you? H2O. Oh! Acid plus a base yields a salt plus water. Always. This is an acid-base neutralization. The pH of this guy is going to be neutral, and the pH of this guy is going to be neutral. Okay? This is what we mean when we say that we're combining an acid plus a base. They're both going to break up, and what makes the hydrochloric acid acidic? The H. And what makes the sodium hydroxide basic, the OH, are then going to combine to give you your water. So that's where that comes up. As soon as you see a salt and a water in the reactants or in the product side, you know it's an acid-base neutralization. Okay, that water's got to come from somewhere. So you might very well be given an equation that's missing one of these molecules. Okay? And if you see that the H2O is on the product side, you know that an acid-base neutralization is happening. Okay? We're going to practice these questions. But basically, what we're doing here is if you've got something that has a -2, what do you have to add to it to bring it back to 0? You have to add +2. So if you've got something that's below 7 on the pH scale, let's say something that has a pH of 5, what kind of substance are you going to have to add to it to give you a neutral pH? Something that has a base of, what's 2 plus 7? Something that has a pH of 9. Okay, 9 is 2 away from 7. 5 is 2 away from. That, if you add both of those substances together, they bring you back to that neutral pH. So that's what we're doing when we look at an acid-base neutralization.